Let's talk about process management. Before talking about process management, let's see what a process is. What do I really mean by process? There are two words which you must be listening for a long time. One is program and other is process. So I'll just differentiate between what these two are. So whenever you write any C program, it will look like this. For example, if you have written the C program example.c, right, and now this one will be given, this program will be given to the compiler, right? And what will compiler do? Compiler will just convert this high level language. Generally your C program will be in the high level language to a low level language, which is machine level language, which can be executed on the machine, right? So now see, operating system's task is not to take a high level language program and execute it on the machine. Before doing this, you should convert it to the machine level language, which operating system will understand, and then it will directly run on the hardware, right? So now compiler is going to generate something like, assume that a.out. So a.out is a file which contains executable code. Executable code means the machine code, right? So either this one or this one, these two are called programs only, program, right? And now this program is going to reside in the hard disk of your memory, hard disk of the computer, right? So hard disk means the secondary storage. See, I say that I generally use the terms primary memory, which means RAM, and hard disk, which means secondary memory. So secondary memory is generally the hard disk, and everything else is comes under primary memory. So we are mainly using, we even call it as main memory, secondary memory. Main memory is RAM and secondary memory is disk. Now this program will generally reside in the secondary memory, right? And now in order to execute it, operating system will take that program, right, and then put it in the main memory and then start executing it. So when it puts in the main memory, it will create some kind of structure, some data structure. So that data structure is going to look like this, and that is what we call it as a process. The process is something which is created by the operating system in order to execute a program. So before you execute a program, you are supposed to create the process, right? So the relationship between process and program is, you can take of it like this. A process is something which is real, and a program is something which is virtual, right? Or if you want to see this, a process is something which is like this body, and the program is the soul, right? So soul, you cannot actually, it is like a virtual concept, right? But then body, yes, it exists physically. So a process is body and program is soul. You can think of it that way, okay? And now see this. So whenever we want to execute the process, then the operating system will create something like this. It will create a structure like this. This structure will be created in the main memory, right? And your .exe code or executable code, whichever you wanted to execute, will be here, a.out. That is .exe file which you got, right? And above this, in your program, sometimes you have some variables which are called as static variables. Static variables means these variables will be created once, and then they are going to remain forever throughout the lifetime of the process, right? So they are called static variables, and global variables. Global variables are also kind of static variables which have to be given access to everything in the process. Okay, global variables, I'll talk about it later in some other subject, but now understand that these two variables, static as well as global, are supposed to be created once, and they are supposed to be existing forever. So they are going to be there forever, right? And then the remaining space is actually not divided, but then you can think of it like a not strict division, right? Something like this, where you could imagine it this way. In any program will contain a need for dynamic allocation. Dynamic allocation means like heap, right? So malloc, calloc, all these calls. The reason is we don't know what the requirement we might get, therefore we will not declare the data structures unless they are required. So therefore we have to have some space which will be used by the process later at some point of time whenever it is needed. For that reason, heap So heap will be here, right? And then every process is supposed to contain something called as stack. So what is the advantage of stack? For the recursion calls, right? For the function calling we need stack. Therefore stack will be there. It is also called as function stack. Stack will be there, heap will be there, static variables, global variables, and then the executable code. Now after creating this, CPU will take one by one the lines available in the executable code and then keep on executing them. While executing them, it might sometimes have to refer the static variables which are present in the same program. That is why that will be present in the same process. This entire thing is called process boundaries, right? So everything that is required by this process will be in this, and operating system while executing this particular process should never cross the boundaries of this process, which means anything that you write here should access only this part. You should not write any access to the other part, then you will get segmentation fault in case if you try to access some other part. So this program is completely restricted in such a way that you are supposed to use only the elements present in this part. You are never supposed to go outside and refer something else, right? So now this part is static variables and global variables, and this part is heap, and this part is stack. One important thing about heap and stack is heap will grow upwards and stack will grow downwards. In the sense, they both will not grow upwards. The reason is, if I grow both of them upwards, I don't know where to start each one of them, and I don't know, in some programs stack will take more space, and in some programs heap will take more space, and I don't know which one is going to take how much space before executing it. That is why I want to keep my options open. So whichever takes more space will occupy more space in this, and whichever needs less space will actually shrink down, right? That is how it can be taken advantage. It is like this: you are having a book in which from one side you are writing the TOC and other side you are writing the compiler design. Then you need not write TOC from half initial page and compiler from the mid page. You actually write it from the opposite sides, because you don't know which one is going to take more space and which one is going to occupy the complete book after some time, isn't it? Similarly, we don't know which one, therefore this is the kind of implementation we are using. So this entire thing is called a process. So this is the program either this one or this one is the program which will generally reside in the hard disk. And once we try to execute this, then for this particular program this entire thing will be created by the operating system, right? And now this one will be given for execution to the CPU. Now CPU will take each line from here and then refer to the elements here, or use this rough space and then try to finish the execution. So that is how it is done. So this is the body and this is the soul. This is the soul, right? And if it doesn't have any soul, CPU cannot execute it. It is as good as dead man, isn't it? If you don't have any instructions to execute, even if you give that entire structure to CPU, what will CPU do, right? Now, how can you identify process? See, given these many processes in the operating system like this, we have so many people in the world, right? Then how can you identify each one of them? We are going to use something called as identification cards, isn't it? Identification card is going to say, see, this is the ID number, maybe driving ID, and then this is the name, and then this is the age, and this is the status. Everything will be there, right? Similarly, when we have these many processes created in the memory randomly at any point of time, we are supposed to keep track of which process is what and how many processes are there, and what is the current state of the process, what is happening with it, is it running or is it blocked, or what should I do? So in order to identify everything, we are supposed to have some bookkeeping work. It is like this: every process will now be given an identity card, right? Now it is a newborn baby, right? It need not be newborn, it might have taken some time, and now it might have grown up already. Anyway, whenever anything is born, any process is born, operating system is going to give it some ID card, right? Now that ID card is going to look like this. That will contain all these attributes. One attribute is process ID. So process ID means every process will be given some number, right? That is called process ID. Why is it useful is, we cannot obviously name a process, right, like how we name the people. So that is why it is a unique number which will be given to a process in a computer. Every process will get a different number, and coming to this process ID, it is not like port number. Port number is universal, everyone maintains the same port number, but here the process ID Here the process ID is actually different in the sense, it depending on the operating system, some operating systems will use 16 bit, some operating systems will use 32 bit, like that. Okay. And next one is program counter. Program counter means while you are executing a process, a program, here the process, you suddenly stopped the process and again you restarted it. Then from which point should you actually start the execution? Which means, assume that we have like 10 instructions, I1, I2, I3, so on, I10, and say you stopped the execution after I6. You executed I6 and then after this you stopped the execution and then you removed this process and then you executed some other process and later again you started this process. Then after this instruction, what is the next instruction you are supposed to execute, right? So that is what we wanted. So for that reason we use something called as program counter. Program counter will contain what is the next instruction that has to be executed, right? So that you can keep on executing it without any repetition. That is just to maintain that. Okay. Next one is process state. So what is process state is, I'll tell you. There are various states. Next I'll tell you what the states we have. But anyway, like this, ready. States will be like this: ready to run, or running, or blocked, or waiting, anything. I'll show you this later. And next, priority. Priority is, it shows the importance. So whenever any process is created by the operating system, then it will generally assign something called as priority. A process which is having higher priority is supposed to execute first compared to the process which are having lower priority. For example, if you have an operating system process, then it should be given the highest priority because it is important compared to the user process, right? Therefore, depending on that, we assign some number. Priority is nothing but a number which will be given to the process whenever it is having created. For example, it is like this, priority given. Now coming to this priority is a number. You can compare it this way. Politicians will have higher priority compared to normal people. Therefore, when they are going on road, the road will be blocked for others. Similarly, when a new process with higher priority enters the environment, then that one will be given higher priority and everyone will be blocked, or everyone will wait until it finishes, right? So like that, priority will be useful. And now there is something called as general purpose registers. So general purpose registers means when you are executing a program, some program, then what happens is the CPU will make use of the registers, right? And now when you pull out that process, now these registers will contain some numbers, and if you pull out that process and put the next one there, okay. Now I was talking about general purpose registers. Now general purpose registers are like this. If you have a CPU, so if you have a CPU, now it will have some registers. So register R1, register R2, register R3, like this. Okay. And now if there is a process P1 and if it is executing on this CPU is executing this process P1, during its execution it will be having some numbers which are stored in registers. For example, here the number stored is 1, number stored is 2, number stored is 3, right? And now this process, let us say the next instruction which has to be executed is I4, the instruction number, and let us say I4 is R1 equal to R2 plus R3. This is the instruction. Therefore, a process will even refer to general purpose registers during its execution. It is not just that it is going to refer only to the elements which are present in the process. It will even refer to the general purpose registers. Now, if this is the next instruction that has to be executed, assume that at this point of time P1, this particular process got preempted. Preempted means stopped. For some reason it got stopped. What are the reasons? We shall see them later. And then the other process P2, it got to be, now P2 has to be executed. Some other process, it came for execution. Now CPU is executing this, therefore P2 will definitely change the status of this, right? So let us say it is changing the status from here 5 and here 6, right? And after for some time this P2 left the CPU and again P1 got executed, and therefore by looking at this program counter we know that the next instruction which has to be executed is I4. So I am going to take I4 and execute it, but then when I execute this one, R1 will be R2 plus R3, which means R1 will be 5 plus 6, which is 11, right? But then actually it has to be 2 plus 3, which is 5. So whenever you preempt or whenever you stop any process and take the next process for execution, you should even make sure that the general purpose registers, the state, the what is present in the general purpose registers, they also should be stored at some point, at some place, so that when you again come back, the entire state of the general purpose register should be restored, right? So that is why it is called as general purpose registers, which have to be stored, right? And next one is list of open files. So list of open files means during the execution of the process, some files are going to be opened, and some files will be opened for reading, some files will be opened for writing. Therefore you are supposed to remember what are the files which you have already opened, so that later when you again come back for execution after preemption, you should know which one you have opened, so that you will not again open it, or you will at least close it, right? So why is this one is useful is when many process are using files, you should make sure that the same file, even if it is written by two processes, it should be consistent. Therefore sometimes you should know what are the processes which are opening some files, and for a given file what are the processes which are opening it, and for a given process what are the files it opened it, because whatever modifications you do on the file system is now going to reflect on the processes, right? So later what happens is, if a particular file is closed which is already being read by process, then before closing it you will just go through all the list of processes which are opening this, and again you inform them that we are going to delete this file or something like that. Next one is list of open devices. So open devices means you can think of it like this, that printers, scanners and hardware devices, and you should maintain a list of it. Production. So production is like this. You are not supposed to get into the other process workspace. Similarly, other processes are not supposed to get into your workspace, right? So operating system should protect you from others, as well as it should stop you from accessing the others data. So every information will be maintained in this, right? It is a kind of identification card, like how our identification cards work. Here also the same way it will work. Now where will all this information be present is, it will create something called as, for every process it will create something called as process control block. In this process control block the entire information will be present. So for every process we get one process control block. Let us say this is the process control block for P1, and this is the process control block for P2, process control block for P3, right? So on. For all the process we have process control blocks, and all these process control blocks will be present in a linked list, right? So you can know by looking at this list of process control blocks how many processes are executing, how many processes are there in the system, and then which one is doing what by looking at the state of it, and then you can know what are the files used by each one, and many things, various things, everything you could get it from this information. Understood this? So this is the list of PCBs which is going to indicate everything about the process. A particular process can be identified using one PCB, but all the processes, if you want to know about them information, then you can look at this list, right? Everything is maintained by the operating system in a linked list. Okay.